Developers a powerful new tool just as rasterization plateaus. Let me show you some amazing footage from games in development. The technology and artistry is amazing. Omniverse from the perspective of two applications, design collaboration and digital twins. There are several major parts of the platform. First, the Omniverse Nucleus, a database engine that connects users and enables the interchange of 3D assets and scene descriptions. Once connected, designers doing modeling, layout, shading, animation, lighting, special effects, or rendering can collaborate to create a scene. The Omniverse Nucleus is described with the open standard USD, Universal Scene Description, a fabulous interchange framework invented by Pixar. Multiple users can connect to Nucleus, transmitting and receiving changes to their world as USD snippets. The second part of Omniverse is the composition, rendering, and animation engine, the simulation of the virtual world. Omniverse is a platform built from the ground up to be physically based. It is fully path traced. Physics is simulated with Nvidia PhysX, materials are simulated with Nvidia MDL, and Omniverse is fully integrated with Nvidia AI. Let me show you what talented creators are doing. Ericsson is using Omniverse to do real-time 5G wave propagation simulation with many multi-path interferences. Twin Earth is creating a digital twin of Earth that will run on 20,000 Nvidia GPUs. And Activision is using Omniverse to organize their more than 100,000 3D assets into a shared and searchable world. In this video, you'll see Omniverse's physics simulation with rigid and soft bodies, fluids, and finite element modeling, and a lot more. Enjoy. We're working with BMW to create a future factory, designed completely in digital, simulated from beginning to end in Omniverse, creating a digital twin and operating a factory where robots and humans work together.
Welcome to BMW Production, Jensen. I'm pleased to show you why BMW sets the standards for innovation and flexibility. We are inside the digital twin of BMW's assembly system, powered by Omniverse. For the first time, we are able to have our entire factory in simulation.
Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory for mission control. They can monitor in real time complex manufacturing cells, update software over the air, launch robot missions, and teleoperate. When a robot needs a helping hand, an alert can be sent to mission control, and one of your associates can take control to help the robot. GeForce Now is NVIDIA's GeForce in the Cloud service. GeForce Now serves 10 million members in 70 countries. Incredible growth. GeForce Now is a seriously hard consumer service to deliver. Everything matters. Speed of light, visual quality, frame rate, response, smoothness, startup time, server cost, and most important of all, security. We're transitioning GeForce Now to Bluefield. With Bluefield, we can isolate the infrastructure from the game instances and offload and accelerate the networking, storage, and security. Though we're just getting started with Bluefield 2, today we're announcing Bluefield 3, 22 billion transistors, the first 400 gigabit per second networking chip, 16 ARM CPUs to run the entire virtualization software stack, for instance, running VMware ESX. We're on a pace to introduce a new Bluefield generation every 18 months. Bluefield 3 will do 400 gigabits per second and be 10x the processing capability of Bluefield 2. And Bluefield 4 will do 800 gigabits per second and add Nvidia's AI computing technologies to get another 10x boost. We have a new DGX Station 320G. DGX Station can train large models. 320 gigabytes of super-fast HBM2E connected to 4 A100 GPUs. Over 8 terabytes per second of memory bandwidth. 8 terabytes transferred in 1 second. It would take 40 CPU servers to achieve this memory bandwidth. A CPU cluster of this performance would cost about $1 million today. DGX Station is $149,000. It is estimated that to solve meaningful problems, several million physical qubits will be required to sufficiently error correct. The research community is making fast progress, doubling physical qubits each year, so likely achieving the milestone by 2035 to 2040. Today, we're announcing cuQuantum, an acceleration library designed for simulating quantum circuits, for both tensor network solvers and state vector solvers. The genius of the x86 server architecture is the ability to do a good job using varying configurations of CPU, memory, PCI Express, and peripherals to serve all of these applications. Yet processing large amounts of data remains a challenge for computer systems today. Each Ampere GPU is connected to 80 gigabytes of superfast memory running at 2 terabytes per second. Together, the 4 Amperes process 320 gigabytes at 8 terabytes per second. Contrast that with CPU memory, which is 1 terabyte large, but only 0.2 terabytes per second. The CPU memory is 3 times larger, but 40 times slower than the GPU. Today, we're announcing our first data center CPU, Project Grace. Named after Grace Hopper, a computer scientist and US Navy Rear Admiral, who in the 50s pioneered computer programming. Grace is ARM-based and purpose-built for accelerated computing applications of large amounts of data such as AI. The ARM core in Grace is a next-generation off-the-shelf IP for servers. Each CPU will deliver 300 spec-int, with a total of over 2,400 spec-in rate CPU performance for an 8 GPU DGX. For comparison, today's DGX, the highest performance computer in the world, is 450 spec-in rate. 2,400 spec-in rate with Grace versus 450 spec-in rate today. So look at this again. Before, after. Before, after. Our data center roadmap is now a rhythm consisting of 3 chips: CPU, GPU, and DPU. Each chip architecture has a 2-year rhythm with likely a kicker in between. 1 year will focus on x86 platforms. 1 year will focus on ARM platforms. ARM is the most popular CPU in the world, for good reason. It's super energy efficient. Its open licensing model inspires a world of innovators to create products around it. The missing link is 5G. Consumer 5G is great, but private 5G is revolutionary. Today, we're announcing the Ariel A100, bringing together 5G and AI into a new type of computing platform designed for the edge. Ariel A100 integrates the Ampere GPU and the Bluefield DPU into one card. This is the most advanced PCI Express card ever created. So it's not a surprise that Ariel A100 in an EGX system will be a complete 5G base station. Our partners, Ericsson, Fujitsu, Mavenir, Altran, and Redsys, will build their total 5G solutions on top of the Aerial library. Today, we're announcing Nvidia Morpheus, a data center security platform for real-time, all-packet inspection. Morpheus is built on Nvidia AI, Nvidia Bluefield, NetQ network telemetry software, and EGX.
It starts with a network. Here we see a representation of a network, where dots are servers and lines, the edges, are packets flowing between those servers. Except in this network, Morpheus is deployed. This enables AI inferencing across your entire network, including east-west traffic. With Morpheus, we immediately see the lines that represent leaked sensitive information. By hovering over one of those red lines, we show complete info about the credential, making it easy to triage and remediate.
Let me show you some of our work in AI, basic, and applied research. DLSS, Deep Learning Super Sampling. StyleGAN, AI High-Resolution Image Generator. GANcraft, a neural rendering engine turning Minecraft into realistic 3D. Ganverse 3D turns photographs into animatable 3D models. Face Vid to Vid, a talking head rendering engine that can reduce streaming bandwidth by 10x while reposing the head and eyes. Sim to Real, a quadruped trained in Omniverse, and the AI can run in a real robot, digital twins. SimNet, a physics-informed neural network solver that can simulate large-scale multiphysics. BioMegatron, the largest biomedical language model ever trained. 3D-GT, Omniverse synthetic data generation. And OrbNet, a machine learning quantum solver for quantum chemistry. The world needs a state-of-the-art conversational AI that can be customized and processed anywhere. Today, we're announcing the availability of Nvidia Jarvis, a state-of-the-art deep learning AI for speech recognition, language understanding, translations, and speech. Jarvis supports 5 languages today: English, Japanese, Spanish, German, French, and Russian. We're announcing a partnership with Mozilla Common Voice, one of the world's largest multi-language voice datasets, and it's openly available to all. NVIDIA will use our DGXs to process and train Jarvis, with a dataset of 150,000 speakers in 65 languages, and offer Jarvis back to the community for free. So go to Mozilla Common Voice and make some recordings. Let's make universal translation possible and help people around the world understand each other. Now let me show you Jarvis. The first part of Jarvis is speech recognition. Jarvis is over 90% accurate out of the box. Jarvis also speaks with feelings. Let's try this. The more you buy, the more you save.
The more you buy, the more you save.
I think we're going to need more enthusiasm.
The more you buy, the more you save.
NVIDIA Jarvis, state-of-the-art deep learning conversational AI.
When combined with NVIDIA Jarvis, Maxine offers the most accurate speech-to-text. See, it's now transcribing everything I'm saying, all in real time. And in addition, with the help of Jarvis, Maxine can also translate what I'm saying into multiple languages. That makes international meetings so much easier. Another great feature I'd love to share with you is Maxine's eye contact feature. Oftentimes when I'm presenting, I'm not looking at the camera. When I turn on Maxine's eye contact feature, it corrects the position of my eyes so that I'm looking back into the camera again. Now I can make eye contact with everyone else. The meeting experience just gets so much more engaging.
Today, we're announcing that Orin was also designed to be the central computer of the car. Orin will process in one central computer the cluster, infotainment, passenger interaction AI, and very importantly, the confidence view, or the perception world model. The confidence view is what the car actually perceives around it and construct it into a 3D surround model. This is what's in the mind of the autopilot AI. I want to thank all of you, developers and partners, and a very special thanks to all the NVIDIA employees. Have a great GTC.